Hello everyone, welcome to this quick overview video on my transcript analysis using Graph and NLP repository. So this project extracts insights from Zoom meeting transcripts using TigerGraph and NLTK. It stores the Zoom meeting transcript in a more compact version, runs some NLP and graph analysis, and then produces some visual output for all of the determined insights. A TigerGraph Cloud portal is being used here, and over here we can see that transcript analysis is open and ready. Moving over to Graph Studio, we can see the schema. There is one vertex, namely the speaker vertex, and there are two edges from speaker to speaker, namely asked question and answered question. So pretty straightforward schema. And over here we can see that same schema fleshed out a little bit more in text, and an example of what our graph will eventually look like. And finally, here's a screenshot of the output that will be produced. So we've got sentiment, duration analysis, some visual analysis in terms of charts, and some graphical analysis. And here is one of the charts, and here's one of the word clouds produced. And of course, there will be new insights to come. This is just the first version. So taking a look at the code, in our main file, we see a quick introduction comment, and then our first step is to convert the Zoom meeting transcript file into a more compact version. So here's the sample transcript file that is being used. As can be seen, it's pretty straightforward. There's a timestamp, start talking time, end talking time, name of the speaker, and what they said. This is a script, compact.py, that was sourced from GitHub, and it turns these raw transcripts into a more dense format. So if we look here, we see that same entry, Andrew, but now he's spoken 4 lines all at once. And if we look back at the original transcript, we see that this is the case. He says 4 different things, however, it's all split up and redundant in relisting his name 4 separate times. Next up, we go to a graphical analysis. And to do this, we enter our graph analyzer class. First, we establish a connection with the graph solution. And over here, we can see our credentials stored for accessing that solution using TigerGraph. So over here, we're setting up that connection and we're creating the schema that we saw earlier. And then what we're doing is we're going through this transcript file and we're parsing it and seeing whether a given statement is a question or an answer. So our goal in the graph is to create a representation of the function of each spoken phrase. So whether it's a question, whether it's an answer, who's asking the question, whose question is being answered, etc. So over here in populate graph, we can see that we're adding these speakers and we're adding these edges for whether a question is being asked, whether a question is being answered, and so on and so forth. So now taking a look at Graph Studio, we can go into our speakers graph. Oops, just gonna stay. All right, perfect. Give it a second to load in. And all right, going over to the Explore Graph tab, we can see this is the populated graph from our sample transcript. So we can see those speakers that we had seen earlier, as well as the relationships between them in terms of asking questions and answering questions. So for example, Paul and Andrew have a lot of questions between them, whereas Ringo only asked 1 question, but he did answer someone else's question. Going back to our code, we move on to the next part, namely the NLP analysis. So over here in helpers.py, we scroll up to find what I was talking about earlier in terms of determining whether a given phrase is a question or an answer. So here we can see some question patterns that are predefined, and we're using that to train a mini model that determines when given a phrase, whether this is a question or not. So just a little classifier using NLTK. Sort of going through that here, checking, making sure, and then if it is, returning true. So additionally, we have a few more miscellaneous analyses using NLTK as well. So for example, we see our word cloud here. We're removing all non-essential or stop words, going through all of the remaining clean words, and then using those findings to firstly create a frequency distribution, and then plotting that, and additionally creating a word cloud. Additionally, we have some other analyses such as trigrams, which are common like phrases or words that appear back to back. We've got sentiment score, duration analysis. So here we can see we're calculating the time they started talking, time they ended talking, and then the difference. And we're going through that. Next up, we're going to do the visual output of all of this. So if we run it, give it a second to start up. There we go. So it's the same transcript file as earlier, so no need to compact it. As you can see, the sample and the compact version are already there. We set up the classifier, downloaded all the necessary packages, and now it is attempting to establish connection with that graph solution we saw earlier using TigerGraph. So entering here, we can see that it's creating that connection. Pretty straightforward, using those authorizations stored in that INI file. And once it is connected, it is populating that graph by going through the compacted transcript and extracting speakers, whether phrases are questions, whether phrases are answers, so on and so forth. It's still going there. Might take a few more seconds for it to finish populating. All right, there we go. So here we see one of the charts that we created, but before we get to that, let's take a look at what just happened. So first, the graph was created and it's ready to analyze. Next, we ran some basic NLP analyses on it. So total number of words, trigrams. It seems like a very neutral piece of text, makes sense, it's a meeting. We got duration analysis, so who spoke the most, who spoke the least, how many times people spoke, on average for how long, and then some visual analysis. So first up, we've got a frequency chart of the top 10 meaningful words. So no is the most meaningful, which makes sense according to the trigrams. Next up, we've got our word cloud. So once again, see that no over there on the left. And closing both of those up, we just have one last section of analyses left, namely the graph analysis. So that should be running now. And over here, we're basically analyzing the questions and answers edges between different vertices. And we're seeing, all right, which pair had the most back and forth, how many total questions were asked, how many total answers were given, to get a better sense of what this meeting looked like. So we're gonna give that a second run, perfect. And as you can see, this tells us speakers, most questions, answering most questions, and the pair with the most back and forth. And you can see, yep, it is indeed Andrew and Paul. They definitely have the most back and forth in that meeting. So that is the output given. And going back, we can see that if you want to run your own, you can just upload your VTT file into that folder, run main.py, and it should be good to go. And there are a few things I want to add to it, namely linking topics, semantic graph, and named entity recognition. But for now, this is my project, and hope you enjoyed and have fun playing with it.